we're starting. The quicker we start and get through this, the more time you have to work, which means the less homework you have. Okay, so let's get to it. This graphic at the top, again, sorry that printed a little blurry. It was an image, so it just didn't come through clear. Okay, but that says types of angles, and then it says description in these first two columns, and then an example. Okay, so if you want to write that more clearly, that's what it says. Types of angles, description, example. Okay, so let's start here with the type of angle. The first type of angle we're going to talk about are complementary. So complementary angles. Okay, I think y'all have heard that term before. Have y'all? Yes? Yes. Okay. So does anybody remember what it means? Let's look at the graphic and see if we can logic it out. Okay, so we've got a pair of angles over here. Okay, and what marking is on the corner down here, John? Yeah, that little square marking, you can make that darker or bolder if it's unclear in your image. That is a square in that corner. Okay, and we can see these two individual arcs are labeled as 52 degrees and 38 degrees. Okay, if you can't see it, rewrite it. It's 52 and 38. Okay, what does that add to? 90. Yeah, that's the marking of them together is 90. These two angles add to 90. That's what complementary angles are. Okay, so angles that add up to exactly 90 degrees. Okay. All right. Anybody want to take a guess at what the next one's going to be? Go ahead, Harley.
Supplementary.
Yes, supplementary angles. Oh, I meant to do that in black. Complementary and supplementary, you probably definitely heard together. Vivian, you want to tell us what that is? They equal 180. Good. Okay, so angles that add up to exactly 180 degrees. Okay, that example over there, it's 128 and 52. Now, I just want to clarify something because I'm just anticipating somebody may ask, maybe not right now, but maybe later. Okay, these angles do have arcs, and we talked about congruence markings, and some people may be like, well, why does this have one arc and this have one arc if they're not congruent? Sometimes arcs are drawn just to show what you're labeling. So if there is a label like 52 degrees and 38 degrees, that's what you go by. Now, if they were not labeled and all they had was one arc each, that would be marking congruent. Okay, but the arc right here in this depiction is just showing this angle is what I'm labeling 52 degrees. This angle, bless you, is what I'm labeling 38 degrees. Okay, does that make sense? Okay, if there is no label of the actual degree measure, then yes, arc or tick marks on an arc can mark congruence. Okay, all right. So just supplementary and complementary. That's what we're going to start with here on the front. Okay, so this is not the best example. We need to add something to this to make this what it's supposed to be. It says to find X. Okay, right now you would have to assume that's 90 degrees together because it looks like it. And I really don't want y'all assuming in geometry. We do not assume things are drawn to scale or what they look like. We go by labels and markings. So please add a 90-degree marking so that we can actually calculate them. Okay, if that 90-degree marking is not there, technically I could say there's not enough information to solve that because I'm not going to assume things. Does that make sense? Okay, so make sure you add that 90-degree marking. So what do? All you got to do is subtract. Okay, these make 90 degrees together. We've used 75, so there's 15 degrees left. All right, same thing over here on the right, except this time, this line M is what type of angle? Line
Supplementary or flat.
Well, these two together are supplementary, but just line M itself is called what?
Oh,
A straight angle. Remember, there was right angle, acute, obtuse, and straight. So a line is a straight angle. Okay, it's 180 degrees. Okay, so that is a line. There's no points on there. Okay, so line M is a straight angle. So we can just do the same thing and subtract. We know that the line should be 180 and we've used 118. So what's left?
62.
Everybody good? Okay. So again, I think I mentioned this yesterday, but I'm going to say it again because it is true for a lot of things this year. The math in geometry, the actual calculations that you do, they're not hard. This is subtraction, right? The calculations are not difficult, okay? But what geometry is makes it difficult for a lot of people is knowing all of the vocabulary and the markings of things and all the postulates and theorems and rules that we're going to learn, okay? So it's a little different than, you may have been used to in algebra. It's a different kind of math because there's so much new, and some of it's not new. Y'all heard complementary and supplementary before, okay? But some of it is review of things you haven't heard in a while, and there is going to be a lot of new stuff. But like I said, the math, the calculating part is not usually the hard part in geometry. It's knowing all of the terms and theorems and laws and all of that good stuff, okay? All right, so here, now we're going to mix in some algebraic steps. Okay, we've got 3 angles that form a line. Okay, we just said a line is a straight angle that's 180 degrees. Okay, so this time it's 3 angles. So notice it doesn't have to just be a pair of angles. There can be more. So these 3 angles are supplementary with each other. So how am I going to set this up? Go ahead, Mackenzie. Good. So I'm going to write an equation setting the sum to 180 of these 3 angles. Okay, so I'm going to do 6x minus 10. This one. I'm going to just keep things color coded for y'all. 4x plus 6. And 7x plus 14. Okay, the sum of these 3 angles is 180 because they are supplementary. And you don't have to put the degree symbol in your equation. You just put 180. All right, so we're going to combine like terms first. So how many x's do I have? How many constants do I have? Now I'm ready to move terms with opposite operation. What you do to one side, you do to the other. Opposite operation again. Did they ask me to solve for x or for one of the angles? X, so I'm done. Now, you take it back to algebra. Hopefully your algebra teacher told you, when you're solving algebraic equations like this, you can always take that x and plug it back into your equation and check it, right? Of course. So I'm not saying you have to do that every time, but if you want to be sure that you have the right answer, or if you're unsure, you could always take that 10 and plug it back in for x calculate this and it should equal 180, right? Okay, same concept over here, except this time these angles are what? 90, they're complementary. Okay, let's practice using our vocabulary. These are complementary angles. So this time I'm going to do the sum is equal to 90. Okay, so this angle here, 7x minus 9, plus this angle here is 4x, will add to 90. Okay, how many x's do I have?
11.
No constants to combine. Ready to move with opposite operations. Did this one ask me to solve for x? Okay, so I'm not done. So this one, I just had to solve for x and I'm done. We have to make sure we go back and read questions. So I have to go back and plug x in for CBD. Which one's CBD, the green or blue one? Okay, trace it out. CBD, that's the green one. So I'm looking for the measure here. So that is, x was 9, right? Okay, what's 7 times 9?
63.
Minus 9. And that's an angle, so our units are in degrees. Okay, really, it would be even better to write the measure of angle CBD equals 54 degrees. Okay, again, if it confuses you when I kind of write my work out of order, you can put this was the first thing we did. That was step 1. And then we came back up here and did step 2 to plug it in. Okay, if you need to label that. Questions on supplementary, complementary? Awesome. Okay, flip it over. Vertical angles now, I think this is a new term. I know you've heard supplementary and complementary. Have you heard of vertical angles?
Yeah.
Oh, you have. Okay. Does anybody remember what vertical angles are? Okay. So in this picture, this intersection, can you tell me a pair of vertical angles? Arian?
1 and 3.
1 and 3. Okay. And then McKenna? 4 and 2. So it's the angles that are across from each other at an intersection, right? Okay. What do we know about those angles that are across from each other, Arian? They're congruent, okay? So vertical angles are pairs of, I'm going to say opposite here. So they are opposite angles made by intersecting lines. So I'm going to color code. So 1 and 3 are vertical angle pair. And then 4 and 2. You just want to highlight them if you want to put arcs on, however you want to label them. Okay, but 4 and 2 are opposite each other. 1 and 3 are opposite each other. Okay, so opposite angles made by intersecting lines. What we know about them, if 2 angles are vertical, then they are congruent. Okay. So I can put congruent angle markings in this image. So I could put an arc with 1 tick mark on 1 and 3. I could put an arc with 2 tick marks on 2 and 4. Okay, vertical angles are congruent. Okay, I could write this out. I could say angle 2 is congruent to angle 4. I don't know if you're going to be able to see yellow. Maybe I should switch my color. I'll switch it to green. Okay. Angle 1 is congruent to angle 3. Good with vertical angles?
Yeah.
Okay. Let's try it. This first one, find X and all angles. So what does X have to be? Okay, that one's pretty straightforward. They are vertical angles. This is going to be 35. But now, how can I find the other two missing angles, Katie?
180 minus that.
Good, because the blue, yours is not in color. So on my screen, I have them in blue and green. Those are each a line. And we know a line is 180 degrees. So the 35 is next to this angle 35 and this empty one are supplementary. So you can just subtract from 180. I know most of you can do that in your head, all of you. But for the sake of our notes, I'm just going to show where our answer is coming from. So what is that?
140.
So I'm going to label 145 in these other, and the other one's the same, right? Because those, bless you, because now those two are vertical angles. So I could put 2 arcs on those. The other ones have 1 arc. Okay, now with some algebra mixed in. We can't forget our algebra, so we mix it into geometry a lot. We'll throw those variables in there. Okay, vertical angles are congruent. When I'm setting up an equation, congruent means what? Equal. So I use an equal sign. X plus 16 equals 4x minus 5. Okay, move like terms to the same side. I'm going to move the x to the right so I keep a positive coefficient. You can move 4x to the left and have a negative and you'll divide it out. You'll get the same thing in the end. It's fine. Okay, and we'll move the, since I'm moving x's to the right, I'm going to move constants to the left. Get rid of that there. So I end up with 21 equals 3x, and then I'll divide out the 3. And that's all they asked for, right? If they had asked for all the angle measures, what would I do? I'd plug it back in. Let's go ahead and do it. What is this? What are the marked angles going to be? What's 7 plus 16? Okay, it's self-checking, because if I plug this in, what should this also come out to? Yeah, because these are supposed to be congruent. If I plug this in and it doesn't come out to 22, that means I made a mistake in my solving. So it's kind of a good way to check yourself. Even if they didn't ask you to do it, you can check yourself. Okay, 7 times 4 is 28. 7 times 4 is 28 minus, oh, we didn't add that right. Yeah, I just went with what I heard. I didn't even check it, y'all. All right, we good? So what are those blank angles? Say it a little louder. I didn't hear you.
157.
All right. Everybody cool with vertical angle? Okay. Now, a linear pair. Have y'all heard of that one also? Okay, awesome. Y'all just know everything. Let's just skip to the end. Linear pair is similar to supplementary. When people get them mixed up, they're like, aren't they the same thing? Okay. A linear pair is supplementary, but supplementary is not always a linear pair. It doesn't work in reverse. Okay, because a linear pair, first of all, a pair is how many? 2. So it's 2 angles, and linear means what? What word is right there inside? A line. So it's a pair of angles on the same line. Okay, so linear pair means on the same line. So 2 angles on the same line. Now, if they are on a line, we have already established a line or a straight angle is 180 degrees, right? So yes, a linear pair is also going to be supplementary by definition because they're on a line. Okay, a line is 180 degrees. Now, supplementary angles add to 180, but it doesn't have to be only 2. It can be 3 angles, like that example we did on the front, and they don't have to connect. the examples that we've looked at today all are connecting. Like these two angles we said are supplementary. They're next to each other. They form this blue line. Okay. Or these are next to each other. They form this green line. Or on the front, the examples that we did, okay, they're on a line together. They share a common side. This is a linear pair. Okay. They share a common side. Okay. They form a line together. Okay. But supplementary can be disconnected like this. Okay. They don't have to touch. They can be drawn separately. They don't even have to, these both have one of the sides of the angles horizontal. They don't even have to have that. Okay. So, and they could be drawn completely different directions. So I could draw an angle this way and an angle this way. They don't even have to go the same way, or I could draw one this way. It doesn't matter as long as they have a sum of 180. So as long as I marked this, this is not drawn to scale. This is what I'm talking about. I'm just going to make up numbers. Those add to 180, don't they? So it doesn't matter the direction that they're drawn, okay, as long as they add to 180, they are supplementary. Okay, where linear pair, on the other hand, they have to be on the same line. Okay, they are going to have a common shared side. They are going to touch. They're going to have a common vertex. Does that make sense? And maybe you want to write that. Okay, a common vertex. A shared side. Okay. These do not have to connect. Yes. Yes. Any questions about vertical angles or linear pair versus supplementary? Okay, I'm going to activate the practice. Okay, you're going to get to it through our Canvas. It is Delta Math, but it's through Canvas. Let me publish it real fast. And I'll link it to the calendar. So it should be linked in the calendar now. So you should be able to click and it'll take you directly to the practice, or you can navigate to Unit 1 or go directly to assignments navigation. Okay, it's right here. Okay, don't forget any of these past ones. If they're incomplete, you can finish those first. Okay. Any questions? Okay, use your notes, talk to your table mate, ask me questions if y'all get stuck.